We're going to pick up part 2 of the notes, pretty much where we left off. I forgot one slide on the last one, but just another picture. So here's another picture of this goblet cell, so really not a big deal. But part 2 again is just going to cover connective tissue. So just in general, some characteristics of connective tissue, just so you kind of know what it is. Kind of interesting that it's the most abundant type of tissue by weight. Again, it's nothing you really ever think about or talk about, or really nothing a lot of people typically know about. You typically think of like muscle, nerve, and people usually know what that stuff is. But connective tissue, it's everywhere. It's connecting all parts of your body, bone to bone, muscle to bone, skin to everything else that's underneath it. And so it's pretty important, but just something that typically it's not very popular, I guess. So the functions of this, there are many of them, and for each one you'll see the differences, but just in general they kind of do lots of different things because there's lots of different types. It's less dense than epithelium. You can see this picture here. There are some cells in there. They're intermixed with like some fibers and just a lot less dense material. The matrix, or extracellular matrix, is just all the stuff that exists between cells. If you think about a tissue that's just made up of a bunch of cells kind of packed together, well, just because they're packed together doesn't mean there's space in between cells, and the space in between cells is called extracellular matrix. Again, just made of fibers and stuff, just chemicals, water. It's probably got a lot of proteins in it and stuff. So that's what the matrix is, or extracellular matrix, ECM. You can see it abbreviated quite a bit, ECM for extracellular matrix. Two different types of cells that are found in connective tissue, and they are fibroblasts and macrophage or macrophage, depending on your preference. They're two very different cells. Fibroblasts make fibers that are just made by proteins that are found in the matrix. So again, here's a fibroblast. It doesn't really have a real shape. It's just kind of awkward shaped, but what they do is completely different from the other ones. These guys are making stuff, making fibers, where a macrophage or macrophage is just going around destroying stuff that should be destroyed, foreign cells or parts of cells or things that need to be destroyed. That process is called phagocytosis. So whenever you see this suffix or prefix, depending where it is, phag, it just means to devour, to destroy something. So these fibroblasts that are producing fibers, there's two types of fibers that they're producing. Collagenous fibers, which an easy way to remember these is they're kind of like ropes. They're a little bit stronger than elastic fibers, and they can stretch a little bit, but to a point you can't stretch them too far. So kind of like a rope is. It's flexible, kind of stretches a little bit, but it's really more used for strength. And this is the same case for parts of your body that are using these guys, primarily ligaments and tendons. By the way, ligaments hold bone to bone, and tendons hold muscle to bone. That's how you distinguish between the two of them. So collagenous fibers, a lot different from elastic fibers. Elastic fibers are really stretchy, so these are more like rubber bands. So easy things to write down to remember these guys. Collagenous fibers are like ropes. Elastic fibers are like rubber bands. So they're really stretchy. They're not as strong. You wouldn't want to pull something with a rubber band. You'd probably attach a rope to it. These guys are found in the vocal cords, and vocal cords can get stretched out. People that perform, singers that perform on a regular basis, often experience this, and they have to take a break. They have to let these fibers heal. They have to let these parts heal and basically go back to normal. Two other kind of connective tissue are the first two kind. Loose connective tissue are made of fibroblasts and some fibers. This is the kind of tissue that connects the skin to the rest of the body, so your skin is not kind of flapping around. And you can see it lies beneath most epithelial tissue, so this is a pretty common form of connective tissue. The other one is adipose tissue, and let me first show you a picture. Loose connective tissue, so you can see there are some cells here, there are some fibers here. There's not very packed in. You can kind of compare these when we get to the dense connective tissue. You'll see a big difference. So that's loose connective tissue found in your book. The next one, adipose tissue, is fat. So they're just cells that contain fat. And the fat in this case is usually like oil. And so there's two functions, and pretty unique functions, unique to each other. Protective cushion, which basically your fat just is like a big cushion for other stuff underneath it, and also stores energy. And hopefully you learned something about this in biology class. So two different functions, very different functions for fat, adipose tissue: protection and also for energy. And so you can see adipose tissue there's not much to it, it's just like fat. So cell membrane, nucleus, and just basically some oil inside. And we'll get to talking about these when we get to other systems. Here's a cross-section of the skin. You can see some adipose tissue there. Next up is dense connective tissue, and if you looked at this under a microscope, you can see these are kind of tightly packed in there. A lot more thicker fibers, the collagenous fibers. This is going to hold body parts together, so it's going to hold bone to bone, it's going to hold muscle to bone, right? And typically bigger things, skin cells there. Although the skin you have a lot of skin cells individually are pretty easy to hold together. You can imagine these guys connected to several skin cells, and loose connective tissue connected to a lot of skin cells, whereas dense connective tissue, you're thinking, bigger, stronger, holding muscles and bones. So here's the picture in your book. Not necessarily that it's always really this like wavy, but here you can see the fibroblasts that are producing those fibers, these fibers, collagenous fibers, and they're pretty packed in there. So a big difference between these guys and the loosely packed in, loose connective tissue. You can see the fibers, there's a lot of space in between there and stuff. So big difference between here, loose connective tissue, and what we're currently looking at, dense connective tissue, tightly packed in fibers. Cartilage, we've all heard of cartilage, right? Cartilage is actually very similar to bone, and we'll talk a little bit more about this when we get to the skeletal system. You can see it's a structural model for growing bones. Newborns are made of a lot of cartilage, and that cartilage eventually becomes bones. The cells that create cartilage, and these guys will be important to remember, they are making this tissue, so they're called chondrocytes. So they're basically the cells that create cartilage, and when you see a slide, you'll kind of see a better image, you'll get a better idea of what it looks like. But here are the three different types. Hyaline cartilage is really fine, thin. It's found at the ends of bones. It's found in your nose. Elastic cartilage is a little more dense. It's the external part of your ears. So a little bit thicker material. And then there's fibrocartilage, which is made of a lot of collagenous fibers. It's really dense, and so this forms a good shock absorber. So you can imagine between your vertebrae, I had a picture and I think it made its way not onto this PowerPoint, but between vertebrae, and we'll talk about this too when we get to skeletal system, between vertebrae and joints like your knee and stuff, there needs to be these shock absorbers, these cushions, so that all the weight that your body, or all these pressure that your body puts on these bones, they're not going to cause them to have any damage, or as little damage as possible, I guess. So here's what cartilage looks like. Here are the chondrocytes, all these little guys kind of spread all over the place. They're actually creating the tissue. And again, between the cells, pretty important spot, but we're not really going to focus too much time talking about the extracellular matrix, ECM. And here you can get a good example of where cartilage is found. Some cartilage is found connecting ribs to your sternum. Another picture in your book, this is elastic cartilage. So you can see the fine fibers that are here, fine elastic fibers that are found here. Microscope image, here's an idea of where this stuff is found. The external ear. Your ear is not bone, it's just cartilage. If you look at a skull, there's not ears on a skull, right? It's just a hole. And then fibrocartilage, which again is a little bit dense, more dense. These large collagenous fibers give you a good idea of what I was talking about. Between vertebrae and your spine, there's a lot of pressure over years and years and years of those vertebrae kind of squishing together. So a good shock absorber, a good cushion between them, are these cartilage tissues. Next up is bone, and this is getting to the end of the connective tissues. So again, we probably all know this is the most rigid connective tissue. This stuff is really dense, it's really hard, it's really strong. And again, we'll get into way more detail about this stuff when we talk about the skeletal system, but here are the bone cells, the guys that are making bone. So these are called osteocytes. They're arranged in a very specific way to create all this stuff. And again, we'll get into the details of all this stuff later, but here's when you see this combination of osteocytes, which are bone cells, canals, which are literally just like spaces, and other stuff, it's called an osteon. And so one of these guys right here, this big circle, kind of looks like you're cutting through like a tree, right? It kind of looks like a tree ring. So this is one osteon. There's a bunch of them. You can see in the middle. There's a really dark part of each one of them. And blood vessels are passing through these canals, so it's supplying all this tissue with what it needs to grow, repair, and other things. Here's the picture in your book. Here's one osteocyte up here. You can see they kind of like branch off, these little teeny tiny canals. Here's one osteon, kind of looks like a tree section, cross section. But again, stuff we'll get to when we get to the skeletal system. There's our skeleton. All your bones are made of all this stuff. These are individual bone cells and bone material. There's a lot of calcium deposits and other things in there. All right, at the end of the connective tissues, blood is actually connective tissue, which you wouldn't typically think of it as a connective tissue, but it is. Its job is to transport oxygen, sugar, salts, other things throughout the whole body, and water. A lot of your blood is actually made of water. Blood plasma, this is what this is talking about. It's the plasma is basically the water and maybe some proteins and stuff that is mixed in with your blood. So the plasma is actually the watery part of your blood, and that is a fluid matrix. So we talked about the extracellular matrix. Well, between blood cells, it's basically water. Extracellular matrix somewhere else could be a little bit tougher, could be a little bit more dense, made of other stuff. But with blood, it's pretty much almost entirely water between blood cells. And blood platelets. We'll talk about all this stuff when we get to blood, the unit blood. But an interesting, you could donate your blood plasma, and you can donate platelets, and you can. I'm not telling you to do this, but if you're in college and you are not making a lot of money, not getting too many checks from home, and you need some cash, well, you just go to one of these donation centers and you just donate blood plasma or donate platelets, and you can make like 20, 40, 50 bucks just going in every couple weeks. So not a bad deal, but I didn't tell you to do this. Last one, I'm really not going to focus too much about this. This is the reticuloendothelial tissues found in the lymphatic system, so we'll talk about these a little bit more when we get to that unit. So they're just kind of all over the place. They help to destroy stuff. So they're pretty much found everywhere because your body needs to defend itself everywhere inside. Here's basically the table in your book, maybe simplified a little bit, but it's table 5.5 on page 105. It shows you all the tissues, connective tissues, and what they do. So an important table to memorize, highlight it, write it down, smiley face it, do something because it's something that you're going to want to memorize. Alright, that's going to wrap it up. We're going to go into muscles and nerve next, and that'll be part 3.